Hello, hello, hello. Hi, people. How you doing? You're welcome to another exciting session, mathematics session, Easy Math Tutor. So today we're going to talk about factors, multiples, and prime numbers. Factors, multiples, and prime numbers. So are you ready? Let's go. What is a factor? A factor is a number that can divide into a number without getting a remainder. Okay, so if we have 4, the number that will divide 4 without getting a remainder is 2, because 4 divided by 2 will give you 2 with 0 remainder. Also, 1 is a factor, because 1 will divide 4 and give you 4 without a remainder. Also, 4 is also a factor of itself. So a factor is a number that divides another number without a remainder or by getting 0 remainder. Any whole number is either a prime or a composite number. Now, a composite number has more than 2 factors, while a prime number has only 1 factor. A prime number is any whole number more than 1 that has only 1 and itself as factors. The number 1 is the only number that is neither a prime number or a composite number. Now we're going to do some short examples. We're going to find the factors of some numbers. Find the factor of the following numbers: factors of 10, factors of 18, the factors of 37, the factors of 52, and the factors of 120. And so, let's go right into that. Okay, so there are different ways of writing factors of a number. You can write factors of a number as products, okay? For instance, if we want to write the factors of 12, we will say 2 times 3 times 2. That gives us 12. So the products of all the factors of 12 have been written to give us 12. Also, we're going to go to another level. We're going to look for bigger numbers to write their product. Okay, so let's take 360 as an example. We're going to use the ladder method. Okay, or some people will say the LCM method, but I'll call it the ladder method. Okay, so we'll write 360 down and then we'll break it down into its factors. So we're going to do one other example, and this is a question. Find the prime factors of 225 and leave your answer in index notation. Okay, so this is how it's done. And now, before we continue, I want to remind you to do a little thing for me. I want you to help and subscribe to this channel. I want you also to like this video and share with your friends. Click on the notification button, and I'm not going to go anywhere until you do that. Okay, so let's give you a while. to do that. I'm waiting. Okay, now, thank you very much for subscribing to this channel. So I'm going to give you some practice examples. So find the prime factors of the following numbers and leave your answer in index notation: 50, 216. And don't forget to comment your solution in the comment section or send an email to easymathsonline@gmail.com. Now we're going to talk about HCF. Have you heard of the word HCF in mathematics? That is the highest common factor. When two numbers have a factor that can divide exactly in each of them, that factor is known as a common factor. Okay? So, for instance, we have 10 and 20, okay? And then let's assume 5. We know that 5 is a factor of 10, and we also know that 5 is a factor of 20. Therefore, 5 is a common factor of 10 and 20. Now, so the next stage we're going to talk about is the highest common factor. The highest common factor is the highest of all the factors that are common for a given set of numbers. Okay, so we're going to do a very quick example. Find the HCF of 24 and 36. Okay, in this method, we will break down 24 to its factors, the product of its factors, and we'll also break down 36 to a product of its factors. And then we'll place them side by side, and then we'll cross out the common factors of each of these numbers, and then we're going to find their product. That gives us the highest common factors of those numbers. And now our second example, find the HCF of 42, 63, and 210. Okay, now I'm going to give you some simple questions that you can use to practice. So the first question, find the HCF of these pairs of numbers: 84 and 92, 288 and 360. And now our next topic is a LCM. Say after me, LCM. Okay, that sounds good. LCM means the lowest common multiple. A multiple of a number is found by multiplying it by another number. Example, the multiples of 7 are 7 times 1, 7, 7 times 2, 14, 7 times 3, 21, 7 times 4, 28, and 7 times 5, 35, and so on. So a multiple is different ways a single number can be multiplied to give different values. Okay? Now, what is the lowest common multiple? The lowest common multiple, or LCM, of a group of numbers is the smallest multiple that is common to all the numbers. It is the smallest multiple that is common to all the numbers. So let's do a quick example. Find the multiples of 4 and 6. Now, the multiples of 4 and 6 are, first of all, the multiples of 4 will be 4 times 1, 4, 4 times 2, 8, 4 times 3, 12, 4 times 4, 16, 4 times 5, 20, 4 times 6, 24. And then the multiples of 6 will be 6 times 1, 6, 6 times 2, 12, 6 times 3, 18, 6 times 4, 24, 6 times 5, 30. So we find that there are two common numbers there, which is 12 and 24. So the lowest common, which of those numbers are lowest? That is 12. So the lowest common multiple of 4 and 6 is 12. So this is a quick method for us to find the lowest common multiple of numbers. Example 1. Find the LCM of 24 and 36. HCF and LCM have many applications in daily life. What are HCF and LCM used for daily? To split things into smaller sections, to equally distribute items, and to arrange things in groups and rows. So let's see. So 3 traffic signals change from red to green in 10, 15, and 20 seconds respectively. After how much time will all 3 signals together become green? So how do we solve this? First of all, the 3 traffic signals will change from red to green as follows in seconds. The first light will be 10, 20, 30, 40, 50, and so on. The second will be 15, 30, 45, multiples of 15, and the third will be 20, 40, 60, and multiples of 20. So if you look at the timing of the 3 lights, you'll find out some common multiples showing up in each of them. And it is clear that the 3 signals will flash green together after 60 seconds. Now, this 60 is completely divisible by 10, 15, and 20. And the LCM of 10, 15, and 20 is 60. Hence, this problem is a real-life example of LCM problem. Now, let's take a quick example of HCF problem. Square towels has to be cut from a piece of cloth measuring 16 by 20 meters. What is the minimum number of towels that can be cut so that there is no wastage? The towels are square and length is equal to width. Since there should be no wastage, the edge of the towel should exactly divide the length and breadth of the piece of cloth. The dimensions of the towel is that highest number which completely divides 16 and 20. So here we have a case of HCF. Therefore, the answer will be the HCF of 16 and 20, which is 4. So let's take another real example of HCF. Maya has 2 pieces of cloth. One piece is 36 inches wide and the other piece is 24 inches wide. She wants to cut both pieces into strips of equal width that are as wide as possible. How wide should she cut the strips? And now the solution. This problem can be solved using HCF because we are cutting or dividing the strips of cloth into smaller pieces, which are the factors of 36 and 24, which are common. And out of these common factors, we are looking for the widest possible strips, which is the highest of the factors. So the HCF of 36 and 24 is 12. So the width should be 12 inches. And now we've come to the end of this exciting session. I hope you had a nice time. If you have any questions, you can always send me an email or you can write in the comment section. Don't forget to subscribe, like, and share this video. Bye bye. See you next time.